Hello, hello. I have two announcements for you. First, there will be 20 minutes break at 11:30. I think it's a lunch break. There also be a conference party in Fleda at 7 p.m. today. Admission is limited, so you can get badges to get there in Red Hat booth. And there also will be lightning talks. You can propose one and later vote for your favorite one. And the lightning talk schedule will be proposed 1 hour before the session. A lightning talk session will be here.
So, it's time to begin. Do you hear me? Well, I hope you will. Hello, everyone. My name is Dmitry, and I'm from Red Hat. And today I'm going to talk to you about OpenStack Baremetal project codenamed Ironic. And helping me today is our official mascot, PXE-boots, the bare metal drummer. What's it about? We're going to talk a bit about Ironic architecture, for those who are not aware of it. We'll talk a bit more about drivers in Ironic. I'm going to talk about what we achieved during JUNO release cycle and what we're going to achieve during Kilo release cycle. And first of all, who knows anything about Ironic here? Well, some people do. Okay, and about OpenStack? Okay, much better. I think we should be okay. What Ironic is? It's an OpenStack project for provisioning bare metal machines by leveraging common technologies, and by the way, leveraging OpenStack technologies too, while supporting pluggable drivers to allow vendor-specific functionality to be added. And a bit simpler, it's tool for building clouds consisting of bare metals where each instance occupies a whole bare metal without any hypervisors. Possible use cases include Triple O program, which is a program aimed at installing, operating OpenStack clouds using OpenStack technologies. Building bare metal clouds, say for example, Rackspace on Metal, so provide bare metal instances to the clients. Why? For example, for better performance, for predictable performance, for access to low-level hardware features like GPU, OpenCL, and whatever. There is some interest in using Ironic as a general-purpose hardware provisioning tool as well, because it's pretty standalone. And I read a bit about its architecture. In 30 seconds, it's designed to use cloud APIs and be beneath it to provide some hardware manage. So user uses still all these convenient APIs like Nova, Heat, whatever, and inside Ironic turns to bare metal provisioning. And a bit more details. user interacts usually with Nova API. We have standalone mode too, but it's less popular and maybe less polished too. Nova scheduler finds a node based on the information previously provided by Ironic Nova driver. Nova computes setups Neutron and calls to Ironic API. So Ironic itself consists of Ironic API, a number of Ironic conductors, and each conductors have drivers that actually talk to hardware, and drivers a bit later. Ironic conductors are organized in a hash ring, so we have number of hashes, and each conductor maps to some hashes in this ring, and each node is mapped to the hash by its UUID and is mapped to a conductor, which is going to operate on this node. If conductor enters or leaves, so we add a new conductor or we kill one, hash ring is automatically rebuilt and node mapping updated, and for example, offend node is managed by another conductor after this.
Sorry to interrupt. What's a hash ring in your terminology?
You have a number of hashes. I don't know how to better explain it in English. Have a number of hashes that are somehow rounded, so when you go through these hashes, it turns to the beginning, and you calculate hash for each conductor hostname actually. So, and it's all stored in database. So I have this conductor responsible for some hash, how to call it, some distance in the hash ring, and it's actually several numbers of these distances for each conductor, and whichever node fits, after calculating its hash, whichever node fits in this conductor's range, it is going to be managed by this conductor. Does it make it a bit clear? Okay, so it looks a bit like that. It's not really HA picture, but the idea is, so here color depicts some specific drivers. So we have conductors with different set of drivers, and nodes can be mapped to conductors having drivers, and one more complication over the simple hash ring. So we see that yellow nodes can be mapped to one of these two conductors, and so on. That's all really simple information about architecture. I don't want to go into details too much here. What about drivers? That's probably the most interesting thing about Ironic, because Ironic was Ironic initially appeared as Nova Baremetal driver, so it was solely inside Nova, but with time we realized it's too complex, and now we have actually a lot of drivers ourselves. And Ironic delegates dealing with hardware to these drivers. And drivers is actually just a thing consisting of interfaces. And each interface has some specific role in the deployment process. And I'm going to talk about these roles. So as of JUNO, we had these interfaces or like roles in this process. And again, each driver has one of these of different kinds. So we have power interface, which obviously handles power actions per on, off, reboot. Deploy interface that actually handles putting images on the target machine. We had a special vendor pass-through interface, which can be used by driver authors to provide any additional functionality via Ironic API, whatever Ironic doesn't have like common concept for. Management interface, it's just a set of utilities that didn't fall into other categories, for example, changing boot device, getting sensor readings, and so on. And console interface that provides remote console, for example, shell in the box. Power interfaces actually have this. The most generic is IPMI. It's probably found on the most of server hardware. It's special protocol to talk to special controller on server hardware to manage it. SNMP, it's an interesting driver for hardware that doesn't have anything specific, so it just connected to a device which manages its power, so it can just plug it in or out of power, and that's all. SSH is actually used for testing, so it's driver to talk to virtual machine hypervisor so that we can test it actually without lots of bare metal hardware. So for example, it's VRSH via SSH. It's not for production. And a number of vendor drivers that uses their own protocols for conducting power actions with DLHP and a couple of JUNO CYCLE. Deploy interface is a bit more complex thing because it's actually a mix of two things that we tried to split away, but we probably won't be able this cycle. It's a mix of boot method, which defines how we're going to reach this machine. And to reach this machine usually means put some Ramdisk to run on it to actually conduct deployment, and deploy method, which defines how exactly we'll be moving these images on the machine. They're close, but there's some difference I'm going to explain now. Boot part, we have three options for it. It's PXE, which is pretty well known, pretty much all hardware had it separate. It's actually booting over network using TFTP protocol. IPXE, that's essentially the same, but using HTTP instead of TFTP, which achieves much better scaling because TFTP is slow and scales pretty badly. Virtual media supported by some vendors. It means attaching CD or floppy disk image to the machine via talking to its BMC. So without actually involving any DHCP. It's pretty nice for environments where DHCP is not allowed for some reasons. And for deploy part, we have two options. Our default one is we call it iSCSI. And I have very simple deployment Ramdisk that when booted on the machine, it publishes the whole hard drive as via iSCSI share. And Ironic conductor just mounts this share, puts an image on it, and signals back so that it's finished. And a new cool thing is Ironic Python agent, which is an effort started by Rackspace folks to create a smart Ramdisk written in Python. It is capable of a lot of things, including downloading and writing images without calling back to conductor. It can talk to glance, it can talk to Swift, it can make partitions, and so on. So again, better for scaling, better for debugging, and that's probably our future. I'm not talking a lot about management and console interfaces because in most cases they are just closely related to the power interface. So if you have IPMI power interface, you have IPMI management, drag management, except probably for CNMP, which doesn't have management. And now, as we're talking about status update, I'm going to talk what we achieved during JUNO CYCLE, which was extremely important for Ironic as a project. We graduated as official OpenStack project, so in Kivo cycle will be part of integrated release unless they change the whole situation with it. We had our driver merged into Nova, so now Nova code base contains this driver required to talk to Ironic API for bare metal provisioning. We had actually this IPA work, Ironic Python agent. We had deploy driver for it, support for IPXE. We created this management interfaces that previously we didn't have, actually. ILO and drag drivers for HP and Dell hardware were introduced. UEFI boot mode support also by these guys. And finally, we now support sending IPMI sensors reading to ceilometer. Many more new changes actually refer to this link. I'm not talking about them because they're pretty technical. And now about Kilo Cycle. I'll be talking about things we are hoping to have by the end of Kilo, and it's like May. Some of them already merged, some we are reviewing, some under discussion, so the whole list might change a bit, but probably should be like that. First thing I'm going to talk is, again, about deployment. It's the most important part of Ironic, obviously. We're trying to deal with two types of images, and our default one is partition image. where we have an image containing only a root partition, and you leave to Ironic doing the partitioning itself. So Ironic conductor partitions your hard drive, puts a root image, and that's how it's done. Some folks are interested in whole disk images, where all partitions are already present on it. It's especially important for Windows support, which is not ready yet, but there is some interest, and for Windows, we need this whole disk stuff. And a bit related, we have two boot modes, how we boot the instance after it's deployed. Our default one is PXE-booting again, so we keep kernel and Ramdisk for the user image on the conductor TFTP, and instance every time boots from conductor. But again, it doesn't work for Windows and doesn't work for any more use cases. Doesn't scale that well, so we're introducing support for local boot. And our real challenge is to make all combinations of this work with all drivers. One of the most important things we are trying to achieve during Kilo, and we have a very good progress on it. We also refactored our state machine, which means which states node passes during its life cycle. I'm not talking about previous one because very few people here know Ironic. But in addition to what I was talking about deploying and the opposite process of tearing down the node, we have 3 more operations on a node. Cleaning, something, again, all this may be completely unrelated to virtual machines. It's really specific for bare metal deployment. Cleaning, for example, it's what we are doing after we dropped instance, we stopped working with tenant, and now we're going to be ready to the new tenant. We need, for example, to secure erase hard drive. We don't want previous tenants' data to get to next tenants. Who knows what was there? Applying BIOS settings again, previous tenant could tweak something probably we need to restore. Another process, we call it zapping. It's a bit similar thing, but it's it's invoked by the operator. It's not automatic like cleaning. And it's long-running and maybe destructive operations that operator may again run between tenants. It may be RAID configuration, for example. It may be firmware update, and so on. These 2 actions usually driver-specific. You can do something with one driver. You can do it different way with another. For example, a lot of vendor-specific drivers like Dell's or HP's support all this stuff via talking to BMC. Others don't, and we need, for example, to boot a Ramdisk on a machine to achieve all this stuff, to use Ironic Python engine, for example, which is what Rackspace does, by the way. The third thing is hardware inspecting, and people also call it discovery, and as it's my favorite topic, I'll be talking about it a bit later in more details. And some smaller changes, not all of them actually smaller, but still. Config drive support, again, for those who don't know, it's a way to tell Nova to put some random data to the resulting instance. So whatever you want, it's used, for example, for cloud init. We're adding AMT and IRMC drivers. IRMC is Fujitsu, I guess. We start supporting all kinds of operations with RAID. Actually, a very big change is that we introduced API microversioning. So you can now request a specific set of APIs from Ironic within one big major API. So that's, for example, how we change state machine. So because when we rename state, obviously clients can break. We use different microversion, and I know that Nova is going to do it as well, but we were faster. Also, probably it's not very interesting for you, but we got a separate node state for nodes that are already managed by Ironic, but still should not be provided to Nova for deployment. Again, who worked with Ironic previously knew that once you enroll nodes, it can be taken by Nova. Now we have separate states for it. And hardware inspection, as I promised. It all usually means discovering required hardware properties from a machine, knowing only its power credentials, for example, its IPMI credentials. And please, 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 don't confuse it with thing called auto-discovery. When we enroll new hardware automatically when it just appears. We don't currently do it. I'm not sure if we will, actually. Maybe it's a bit close thing, but it's not about it. What can we discover? First of all, and again, the most important is basic scheduling properties that are required for Nova to deploy, to even schedule on this machine. CPU count, CPU architecture, memory size, disk size. 4 of them now. We need MAC addresses of network controllers. Again, for Neutron to set up networking for us, to set up DHCP, we always need MAC addresses. And Ironic even has its own notion of ports. So in addition to Neutron ports, we have our ports. So where we store these things and then pass them to Neutron when we need it. Some folks want to discover vendor-specific hardware capabilities. It can be really anything, possible boot modes, current RAID level, GPU devices, model name, vendor name, everything. There's a lot of ideas on what to discover this way. One more thing that we are actually doing is idea of matching hardware against some predefined roles or against, for example, Nova flavors, or even creating Nova flavors based on hardware. Again, Baremetal is different from virtual machines. In virtual machines, you can request every size that fits into hypervisor. Here, you can't request half of memory, you can request more memory. You have what you have. So it makes some sense to actually create flavors based on hardware, not vice versa, for some people. And how do we achieve it? One thing that's possible, it's going to be possible within Ironic, is out-of-band, which it means, again, you're talking to your BMC, this small controller on your server. It's supported, for example, by HP and Dell, and probably many more. It's a fast and simple procedure, just a couple of, for example, HTTP calls, swap calls to some IP address. But the problem, for me, the problem is it's limited by what BMC can provide. It's okay for basic scheduling properties, completely okay. It may be okay for some capabilities that you want to discover. And some things, like some people want to, for example, discover which switch ports your machine is connected to. You probably can't do it without actually running this machine and looking, because BMC works even with powered-off machine. Then, in-band means it's, again, booting a special RAM disk on a node. Everything can be done with booting a RAM disk. And that can discover anything that can, in theory, be discovered. It's possible. The problem is it's a complex procedure, and much more complex than doing HTTP calls. It requires a whole boot cycle, which, as you probably know, takes a lot for serious Baremetal. It requires special DHCP configuration, which Neutron can't provide, because we need to tell Neutron or something else to PXE-boot this RAM disk on every unexpected node. Why unexpected? Because we don't know MAC address yet. So it's just not that it's going to appear from anywhere. And due to this complexity, during JUNO cycle, we came to agreement that we're not going to implement it as part of Ironic code base itself. Well, not part of Ironic code base. We've written a separate service for it. It's called Ironic discovery, or I usually call it just discovery. It's a very new thing, but it's already reached its 1.0 version on Tuesday. And it's developed specifically for conducting in-band inspection And its task is set up instance for inspection, set up firewall settings for PXE-booting. Why firewall? Because we need to coexist with Neutron. We don't want instances booted by Neutron to boot our Ramdisk, really. And vice versa, it already works. Neutron is smart enough. So we do tricks with firewall to achieve that. And of course, we process data received from the Ramdisk. And we have opportunities for smart processing, and we even support plugins for vendor-specific processes, all this matching, all this driver-specific capabilities. Of course, it requires a special Ramdisk, and it's provided within Disk Image Builder. And for those who don't know, Disk Image Builder is a triple-O tool to build various images. So we're again reusing OpenStack parts that already exist. And let me talk a bit about Discovery workflow, how it actually works. Again, we have an HTTP API, which is a standard in OpenStack world. You start inspection for giving node UUID. So first step is still you enroll node in Ironic. You have power credentials. You have UUID, obviously. That's all. And so you need for now, you can start introspection or inspection. We use both terms. Discovery requests node details back from Ironic, validates node state. And an interesting part, it fetches attributes from a node that we'll be using for finding this node later on. Because again, when Ramdisk comes back to us, we won't have any clues which node it is. For example, we set 5 nodes on inspection. 1 came back, which one? We don't know. We need some clues. What clues can it be? Our best one is it's actually BMC address, which can be figured out from within the machine, and we have it because we need power credentials. So we can match. If we have MAC addresses already, we can match based on them. Probably we can match on serial numbers, but it's not implemented. It's going to be pluggable one day. So we store all this stuff in local database for later. Update firewall. If we have MAC address already, we need to allow PXE-booting from this node, because otherwise we'll prevent it. And ask Ironic to boot the node, actually. Set boot device to PXE and ask to power on. What's going on next? The Ramdisk, whichever it is, posts collected information back to Discovery. And then we invoke first number of plugin hooks to pre-process this data. Thus, for example, we can support different Ramdisks, actually, not one reference that we have in Disk Image Builder. We can accommodate to Ramdisks that provide completely different format of information, for example. Validation is done on this step too. Then we look up the node in the local database. Again, back then we stored attributes. Now we get these attributes from the data, and we match them to find node UUID that was previously set on inspection. Now that we know node, we can create ports for it using MAC addresses. Again, we have our own ports to execute second series of plugin hooks that tells us which changes to apply to the node, which properties to update, what else to do. Maybe contact some CMDB and fetch some profile from it, whatever. Again, the default one is to update scheduling properties on a node. And that's what works out of box. Then a node update happens, we power it off, and co-inspection done. And after we have done that, we had some more ideas what we can do with Discover-D. The thing we're currently working on, I personally can't work on, is actually support initializing IPMI credentials. Yeah, previously I said we need power credentials to work, but if we allow manual power on, for example, a person would come and press the big red button, we can actually initialize IPMI credentials via our Ramdisk and then store them in Ironic. One idea. Another idea, to use inspection as part of cleaning or zapping to actually verify that we have the same hardware we used to have. Because if a second attempt of inspection reports that we have different memory size, something could change. Probably it's operator intervention. Probably we had something broken, and we need to put note to maintenance. Good idea. Some folks suggested to use discovery for validating trust as part of intro.txt. I'm not aware of details, sorry, but also interesting thing, because they also need to put a Ramdisk there to evaluate all these characteristics. And actually, that's all. I think we have plenty of time, not really plenty, but some time for your questions. And before that, we have helpful links, Ironic itself, JUNO tasks, Kivo tasks, discovery. I forgot to add here our upstream IRC channel. It's OpenStack-Ironic on Freenode. You have link to these slides if you want to get them, because it's web-based. And please give me feedback, whether you liked me or not, whether you liked PXE-boots, our bear or not. He also wants to know your feedback, and thank you.
Time for questions.
Oh. 1 moment, sorry, we have a conflict.
So how do you handle Windows installation in bare metal machines? You kind of explained a bit about it, but I would like to know some more details. Do you just dump a disk image inside the bare metal machine's hard drive or something?
Okay, question is about how we handle the installation of image, right? So again, I won't be coming back, but 2 options. Yeah, actually both involve just calling DD from image to the device, and when we have iSCSI implementation, we have this the whole disk of the machine mounted on the conductor, and we call partet to partition it if it's partition images, or do not if it's whole disk images, and then call DD really to the partition or to the whole disk. So that's answer questions. Okay.
My question is, what's inside of the Ironic? If it use some tool for the TFTP booting, like Foreman or Cobbler or something like that, or it have its own implementation? We usually rely on external TFTP implementation. So if you have just TFTP server provided with DNS mask, and we only switch config that in files on disk. So we write config to this TFTP directory, and we rely on TFTP server to serve them appropriately. Okay. And my second question is, I just quickly reviewed the Ironic installation guide, but I didn't get how I added a specific machine to the Ironic. So that's added when I, for the first time, boot from the TFTP and choose something which add me to Ironic, or how I technically add my physical machine to be managed by Ironic.
So how to enroll machine? We currently require operator to start the procedure. So minimum requirement is to know, okay, I have 100 of new machines, and I have this CSV file, for example, with their IPMI credentials. And I can go through them. For example, Taskar UI has support for just uploading CSV and creating nodes in Ironic. So it's a manual action at first. You can then inspect the data so that you don't have to fill in its memory size, disk size, and so on, or you can do it manually. But first step is manual. We don't do automatic enrollment. I know a lot of folks want it, so we power on the machine, it boots from TFTP, and then it appears, kind of what Foreman does. We, for now, don't do it because, probably because of possible side effects if you, for example, boot a wrong machine. we may consider it later, but because if you are enrolling it this way, you have to set IPMI credentials because you don't know them. You don't know these IPMI credentials in advance. And setting IPMI credentials on the machines that just came up may lead to mistakes. That's my personal opinion on why we don't do it. We might end up doing it in the future because there's big interest in it. Probably it's going to be part of Discovery specifically. Questions there?
Yeah. The question is around, so you can use the PFD or the PXE mechanism to install an image on a machine, right? What do you use the iDRAC or the vPro for?
What do I use? What?
What do you use you had a stack of things called iDRAC, vPro. What do you use that for?
Please repeat the question.
So question is, if we use TFTP and related technologies for deploying, why do we use drag, ILO, and all these drivers? First of all, we use them for power management. So they are used for booting power on and on of the machine, for management like boot devices. That's not really intriguing because it can also already be done by IPMI, but they have additional features like virtual media, which means we don't need to use TFTP. We just can put deployment Ramdisk directly right, on this, and again, ask to power on all via ILO. And then again, so we can do without, and if we use a local boot, we can do without DHCP at all, for example.
Yeah, we don't need the local boot. vPro and iDRAC you need if you want to do it out of band.
So does that answer your question?
Yeah, it does.
Any more?
What was the most difficult thing which you had to fix to be able to control physical machines?
What is the most difficult thing to fix to control physical machines?
To connect physical hardware to OpenStack.
The big problem is physical hardware is really different from virtual machines, if you mean that. So for example, we still have some problems with Nova scheduler not really understanding this all or nothing approach. So you can't have instance occupying half of the machine. It's always full machine. So there's a lot of tiny details that really differ, and requirement for cleaning, which is not really the case for virtual machines. You just kill it with fire, and all data is lost, go away. And for hardware, all data is there still. So, and of course, anyone with root access on the machine can do a lot of things with hardware. So we have to recover it as well. And inspection process, because again, for virtual machines, it's very simple. You create it. Here you have it, and you have to learn what is inside. Does that answer your question?
Yes. Why do you use iSCSI instead of just downloading a compressed image and then compress it?
Why don't we download image in? Why don't we do it? Why don't we do it on the Ramdisk, right?
Yes, why the Ramdisk doesn't just send an HTTP request instead of using iSCSI?
So what you're suggesting, as far as I understand, is when we boot the Ramdisk, why don't we just download image from the Ramdisk and put it on the hard drive without using iSCSI share at all, right?
Yeah. Yes, downloading. The Ramdisk should download some bigger image from HTTP instead of reading it from the iSCSI share.
Yeah, that's exactly what Ironic Python agent does. It doesn't use iSCSI, it downloads from Glance and puts directly on the machine. There is some problem with image size. So you can't really keep in memory 20 gigs. Well, 20 you can, 100 gigs full disk image you probably can't. So you need to, it's a bit more complex. So iSCSI was our first solution, which is very simple Ramdisk, very simple Ironic implementation. I think we'll be switching to this approach with time. But once we figure out how to write it without downloading, so we probably need to pipeline it from HTTP directly to the disk so that we don't keep this 100 gig image in memory temporarily. Yeah. So it's the next step we are implementing right now, but we first started with simpler thing just. Because writing Ramdisks is pretty specific pleasure, actually. And before we had Ironic Python agent with everything. It is used Python. It's actually systemd service, so we can run anything there. Our Ramdisks used to be very limited in what they can, especially in debugging. There's nothing really architectural about that, I think. Questions there?
What about networking? Who is responsible for configuring the bonding and FP1 subinterfaces? Does it have to be all baked into the image?
To my best knowledge, it's more. Some things we don't yet support, and they are developed still. Most of things we rely on Neutron to do, but probably it's a complex topic. You'd better drop by our C channel. We can talk about it in details because there's a lot of different things going around with Ironic Python agent and with Neutron additions. And yeah.
Well, I think we are almost out of time. Just one question.
1 minute for.
My idea, the ironic way how we can simply and quickly deploy a new OpenStack compute component.
Please repeat.
If ironic can be the way how we can quickly deploy new OpenStack compute component.
So, can we deploy OpenStack compute component via Ironic?
Yeah.
Well, you can deploy anything via Ironic because Ironic is not really involved into configuration of instance. Ironic is about life cycle of the bare metal machine. So if you have appropriate image, and a lot of people have, you have cloud needs to doing initial stuff. It's not part of Ironic. It's already present thing. We just put images, cloud and it starts doing things, and you can invoke Puppet, or you already have image with everything built in, but it's none of Ironic business actually. We are more worried about this low-level hardware stuff. I think we are out of time, so thank you for your attention.
Well, so